Okay, well, let's move on. Now, whether it's planetary systems or the discovery and elimination of pathogens, there's one thing necessary to any adventure or exploration, and that, in my opinion, is navigation. From Amelia Earhart to Kaylee Bauman, from Jessica Watson to Marie Curie, from Vasco da Gama to dung beetles.
Well, could we just back up a bit here? Like, did you just say that navigation is really important for eliminating pathogens? Like, does that really make sense?
I did an arts degree.
Oh, you're being, like, metaphorical.
Does that now make sense?
Well, no, but yeah, but no.
Welcome, Tim. This is Tim, everybody. And can we have a look at this this little video? Tim features in this.
I've been thinking about dung beetles.
Whoa, so have I.
Oh, it's amazing.
They're so cool.
Did you know that they are celestial beings?
Are they like angels? They've got wings.
Thanks. Except I'm not sure that angels live in a pile of shit. So just imagine that this is a pile of shit, right? And this is our dung beetle's special pile of shit. And this is our dung beetle, yeah? So the dung beetle comes along and it climbs up the shit and it grabs its own special little bit of shit. Then it goes backwards.
Whoa.
Finding its way by looking at the stars.
Wow.
That's what makes us a celestial being.
Some dung beetles, they build a tunnel and they have their babies in there and they have whole lives of, you know, day in, day out, 9 to 5 existence, all in a house of shit.
I just got to go to the toilet, sorry.
Did you know that dung beetles can drag 1,163 times their own weight?
Wow. So you know about dung beetles too?
When they leave their homes, they go by a circuitous route. But when they come back, zoop, they come straight back.
Is that like you know, checking the tables on the way out and then going back to the kitchen with 1,000 times your body weight in plates?
I like it. And maybe I can guide myself
backwards
by the chandeliers.
What did he want?
I'm just talking shit.
Extremely talented and extremely famous influencer, Cheddar!
Hi. I'm the presenter now. That's really exciting. And our final scientist for this evening is Associate Professor Emily Baird, whose research is all about insect navigation.
Whoa.
Welcome, Emily.
Welcome, Emily.
Thank you.
Hi. Listen, I just want to see that other dung beetle video I saw before, because, you know, that one, I think it's really, really funny. Can we look at that one?
So this is a very proud owner of a beautiful dung ball. You can see it's a male because he's got a little hair on the back of his legs there. And he's clearly very pleased about what he's sitting on there. And then he's about to become a victim of a vicious smash and grab.
Beetles that love shit, which is inherently fascinating. They actually have some pretty cool and complex behavior. So complex being that they have a compass in their heads, and that's really interesting because we want to know how compasses work. How does a animal like this with a brain smaller than a poppy seed manage to have a compass, and how does it manage to get around in the world?
So how does it?
That's basically the interest in insects and navigation.
Yeah, so how does it manage to have a compass in its head, wouldn't it?
Well, compasses are magnetic, right?
Yeah.
So maybe it's a nanotechnology compass.
Yeah.
Well, actually, this compass is not magnetic, which makes it even more interesting because it's unlike the compasses that we might naturally think of. The beetles are using the stars, actually, the sky, to get around, and as we all know, that's also really interesting.
Yes.
And so how they're doing that in their tiny little brain is what makes this, my life's work.
So it's wonderful. I actually did a little bit of research because I thought that was a good idea, and you said something about the sort of comparison between them and us. I mean, like, was it cognition or something?
Yeah, I mean, knowing the discussion about cognition and what that is a very deep and long one. But at some point, how intelligent behavior arises in brains like this is something that's something we don't really understand, and something that makes for really interesting research. So how can these beetles do something as complex as navigating and finding their way through the world with something that we naturally would think requires a much larger brain to do?
Yeah. No, I really agree with you. Tim, you're looking a bit thoughtful.
Yeah, well, like, each brain is made up of neurons, right, which are really small. So even though it's only the size of a poppy seed, that's probably like trillions of neurons, right? And how do they all, like, interconnect and stuff? Do we know that?
So they have something around 400,000 to 800,000 neurons. So trillions is a little bit of an overestimate, but we know how neurons connect, and we know that they create circuits that compute information, which is the same for our brains as it is for their brains. But exactly what information they compute, how these circuits are built, and how flexible they are is something that we can study by looking at the behavior of these animals.
So there's also, people talk about the hive mind, that bees and ants and, I don't know about dung beetles, maybe they do too. Is that a thing that they are sharing their intelligence, sort of, and that's why they're more intelligent than just one poppy seed?
Well, in a way, yes. They, without really knowing it, they are creating like large communities of insects, like the ants, and so the bees can create quite complex behavior just simply by each individual having a certain threshold or desire or need to do something, and all the other individuals essentially having something similar but a variation. And this can create actually really stable systems, such as finding the shortest path to food, for example, even though they may not know exactly where the food is to begin with.
That was. Were you going to say the same as me?
I don't
that
know.
was just like our video when we were talking about that with the beetles going. They go out sort of foraging for food, and then they go zip straight back. But is this sort of stuff useful? I mean, I think I read something about you talking about robots. I mean, how can studying these insects help us as humans? Not that we need to have them help us, but we could, and so why not? So how can studying beetles help us?
Well, for example, one of the only ways we currently use to navigate that humans have with human-made machines is by using GPS. And that's all well and good as long as you have access to satellites and a clear view to satellites. But if you are going underground in cave systems, or if you're in a place where there are no more satellites, or you don't have these systems take a lot of energy. So it takes a lot of energy to send and receive signals, whereas what the beetles are doing is something that requires very little computing power. It doesn't require access to satellites, and so it's actually something that can work quite independently. And for somewhere like Mars or exploring space, when we explore planets, it's good to have systems like this. So actually what the insects can do is provide inspiration for the development of systems that allow us to navigate without necessarily requiring a lot of energy or a lot of prior knowledge about where we're going.
So what you're saying is that even though we're sort of smarter, that they're smarter than we are?
Well, one can put it like that. It's their advantage is that they've been evolving over millions of years, so their systems have been refined, whereas ours have not had quite so long to develop. So we can say that by studying them, we're shortcutting over millions of years to get to a really good solution. So
wow, we might
they're
one
smarter
day
in a way.
become as intelligent as an ant.
I'm sorry, did I
Or a whole
interrupt you
lot of
before?
ants.
Oh, yes. Look, I know that you're doing some work
nice to
with
meet you.
bees. So you've been to South Africa, I think, to work on dung beetles. But can you tell us a little bit about what you've been doing with bees and where you're working now?
So I'm really interested in how bees are quite different from dung beetles they navigate through the world, but they do it in the air, which is more difficult because knowing how far you've gone is really difficult if you're just flying through the air. But I'm also really interested in how bees that navigate, there's bees that navigate more than 10 kilometers through a rainforest and find their way back to a tiny small stick.
Whoa.
How on earth they do that, whereas there's also bees that up in the Arctic that are doing similar things, but in a very different environment. So I work in the Arctic with bees up there, also traveling over very long distances, a lot of snow with very little features, trying to understand how they find their way back home compared to bees that live in the dense jungles of Panama. And what are the differences, or do they have these special adaptations to be able to do this in different environments, or are they flexible enough, are their systems flexible enough that the same system works in both of these cases?
Do you go to all those places?
Yeah.
What Panama
Yes,
did you say, and Arctic?
Yes, Panama and the Arctic Circle and Brazil, yeah.
Wow.
I've been a lot of different places looking at bees.
And what made you go to where you are now?
A love of science, the right, as we were talking before, about having groups of people around you that help you do what you do. In Sweden we have there's a really strong research groups that look at these sort of things, or that can help me understand these sort of questions. And apart from Sweden being a very different place to Australia, it's somehow very exciting. It's doing research here is really fun. There's a lot of people interested in similar things. Make it really, really good to be around them.
So how different is it over there from here? It's cold here.
It's actually nearly 30 degrees today.
Wow.
And we're just at the end of summer, but we have really long days. So in the middle of summer, the sun rises about 3:30 and sets at around 11:30 at night. So you get these beautiful long summer days, which is really nice. You can enjoy the day for a lot longer than Australia.
Do you see the Northern Lights a lot?
I have seen them when I've been in the Arctic, yeah.
Do you mind if I ask a question?
Yeah, I don't want you to ask a question. I want to keep asking questions.
Well, too bad.
Okay, go on. I was just joking.
Okay, so now you were talking about how these flying insects, bees, are able to go so many great distances away from their homes and able to find their way back. Can you tell us a little bit about the kinds of experiments you're doing in the laboratory to work out how they do it?
Yeah, so bees are a really great system to work with because they feed for the hive and not for themselves. They will easily find their way to a food source and then find their way repeatedly back. So they can learn to fly somewhere. So you basically can train them. So if I want them to fly, for example, along a tunnel, I can do that by giving them some sugar water, which they really like, and basically move it step by step. And then I can modify the environment that they have and look at how their behavior changes. So, for example, I can completely take away the visual information and look at how that affects their ability to find their food, or manipulate them in other ways and look at how the behavior responds. So to try and get at how the brain is actually processing the information that we're giving it in order to find the food.
So it's kind of bee training.
It is bee training. I do a lot of bee training, yes.
Are they like as good as a dog? Can they sit and stuff?
I would say they're actually smarter, easier to train than dogs. They have fewer needs, or So and this is partly why we work with them, because their behaviors are relatively basic. And so then you can, for example, at the moment we're training bees to recognize three-dimensional objects from two-dimensional representations of them. I think that would be possible with dogs, but probably take more than the few days that it takes with the bees.
Wow, that's like art.
Yeah,
You're
do you know?
teaching them art.
Do you know? I don't know what's more interesting, the talk about the bees or the talk about your life. But just what's the biggest adventure you think you've had?
Oh, I would say science in general, to be honest. It's a massive adventure. It never changes. I'm sure the others will agree with me that this is, a lifelong journey where you constantly have unexpected things happening and meet incredible people, and or have things like breaking down in the middle of the night in the middle of nowhere in South Africa and wondering how you're going to get somewhere and why you thought that this was science was worth at least worth doing this for. But it's you end up with, I think it's constantly unexpected, and that's what makes it science itself so
have you taken
fascinating.
The approach that our scientists from yesterday have? We started talking, and one of them said that she fights wearing armour and with a sword. And then the other one said, "Oh yeah, I've got a black belt in karate." And so yeah, it seems women scientists are, like pretty good at looking after themselves. Did you have to use these kind of skills in South Africa?
Well, I train to run and cycle very fast. So yeah, my response is not to defend, but to run away.
Okay. Now. A lot of people in the world are very concerned about dwindling bee populations. We actually spoke to a scientist yesterday who's working with krill, and she told us that krill are managing extremely well to survive the climate crisis that we're all having to live through. What about the bee populations? How much of a concern is that really?
It's a huge concern. It's firstly because a large proportion of foods that humans eat rely on insect pollination in general, and bees are some of the most important pollinators, especially in the northern hemisphere, but also the southern hemisphere. But another reason is that, it's not only this direct pollination, but that people don't think about so much, but bees are a really good indicator of insect biodiversity in general. And if the bees are declining, that essentially more than likely means that many other insects that we haven't really studied, don't really care about, but maybe having really important ecosystem services, they might also be declining as well. So it's not just actually about our cucumbers and tomatoes and things, but about our general biodiversity and ecosystem health in general. Oh, well, we need to work out what it is that's affecting these insects, and a lot of it is large-scale agriculture and large-scale use of pesticides, which in general is no good for anyone. The bees are just an indicator that it's no good for them, but it's in the long run not likely to be good for anyone at all. And then it's also creating the ecosystems that work, and in Australia it's clear these things, when you don't look after the land as it naturally should be, then you might end up with these enormous scale bushfires and things where it's just general. We need to look after the environment in a way that it has developed for. And the problem with rapid climate change is that while the world has been adapting, and biology, also organisms have been adapting to climate change for millennia, they can't do it in such a rapid scale. And so we really need to try and keep things a bit more stable than they were, in order to keep both the bees happy but also everything else more stable.
Yeah.
Wow.
It's sad.
Now, listen, I just have one more question. Can you tell us the difference between a honeybee and a bumblebee?
Yeah, they come from different places, although they originated, sort of in India probably. But honeybees are generally adapted for warmer climates. They're invasive. They're not native to Australia, for example. And they're not capable of pollinating in warmer climate, in colder climates. But they also have shorter tongues. So bumblebees, there's many different species, but some of them have very long tongues. So they're specialized for pollinating plants with deep corollas. Honeybees can't get to them. Their tongues are just too short. So to have to be able to pollinate flowers that are deeper or that require some shaking to get out, like tomato plants, for example, they require the pollen to be shaken out of them. Honeybees can't do this, whereas bumblebees, they have a brilliant system where they clench their jaws onto the flower, they uncouple their wing muscles from their wings, and they vibrate really high frequencies, and they get the pollen out, and that way they can pollinate tomatoes, which is something that honeybees can't do.
Is that bumbling?
Yeah, something like that.
So what about, I think we have native bees in Australia. How long are their tongues?
There's a variety again, and there's fascinating bees in Australia, even ones that can do this, what's called buzz pollination, what the bumblebees do in northern hemisphere. There are these wonderful bees, they're called Amygilla, that can do this, or the blue-banded bees that actually can do this, that are Australian native. And there's a huge a variety of Australian native bee species that have all different tongue lengths. The problem is that the introduced honeybees have been out competing them. They're far more vicious and sort of larger colonies, and they basically take the food resources away from these native bees, which means the bees can't really survive well.
They're like colonizers. That's terrible.
Yeah.
Wow. Hey, I have to ask a question that, is kind of on everybody's lips in a way, that, there's lots of jokes around about dung beetles, and, how do you cope? Because you must just be the butt of all these really shit jokes all the time.
But I'm a cause of a lot, I'm the basis of a lot of the jokes. I find them funny as hell, so I don't know.
Is this why you became a dung beetle researcher? Because you like making poo jokes?
Have you got a joke
it's
for us?
It's certainly why I stay one.
Do you have a joke for us?
Okay, a dung beetle walks into a bar and says, "Is this stool taken?"
Oh, no.
That's terrific. Mayru, did you have any questions for Emily?
I've just got to go.
Oh, do you?
It's that talk about poo again. Bye.
Oh, thank you, Cheddar.
Thank you, Cheddar.
Sorry, I preempted that. Mayru, any questions?
Very interesting work. I'm fascinated to hear how you got into this field.
Yeah, I'm fascinated to know as well. Basically, I didn't know what I was going to do at university, and I did 2 degrees, one in arts and one in science, and from philosophy to neuroscience, and I couldn't really decide what to do, so I decided to continue at university and do an honours degree, which became neuroscience. So it was a choice between philosophy and neuroscience, and started working a bit with animal behavior, which somehow tied a bit philosophy together, and then I continued, and it sort of wasn't really, let's say it wasn't like Rajika knowing, I knew I always wanted to work with animals. Insects was a little less clear for me, but when I learned that you could train bees and work out how their brains could work without actually having to kill them and cut them up, it was sort of something that was extremely exciting. And then I sort of fell into this world of other researchers that do similar things, and the dung beetles were part of it, and it's you just can't let that go. It's way too much fun.
And Rajika, do you have any questions?
Yeah, I guess I have a pretty simple one. In Copenhagen, when I look up at night, I barely get to see the night sky, and light pollution is getting it's a big problem all over the world. Does this affect dung beetles much since they use the stars to navigate, or are they mostly in very remote areas?
Yeah, actually, my colleagues in Lund, Marie Dakia, who's leading this project, she actually has recently done a study on this about, so they had dung beetles in Johannesburg and in our field site, which is chosen to be far away from light pollution. The dung beetles, they're quite simple because they see the stars just as, or the Milky Way particularly, as just a bright spot in the sky. So they're not really that poetic in there. They don't care if it's a bright spot or if it's a street lamp. For them, it's okay, but absolutely, it's very clear we've been doing a lot of analyses of the night skies, the difference in the light pollution and the stars that can be seen. And for other animals, it's more than likely that dung beetles are not the only animals that use the Milky Way to navigate. It's likely to be extremely disrupting, and it is very concerning about how that might affect, especially migrating animals. I think the bogong moths, Eric Warrant, also at Lund University, but also Canberra, has been finding that bogong moths are using the Milky Way to navigate as well, and how that might affect their migration if they're flying over places like Canberra with a lot of light pollution. It's probably not going to be good.
But it is still absolutely extraordinary what they can do. Listen, we've got a few questions from our online audience. They've been coming through, well, maybe not thick and fast, but,
Well, it's definitely Shonley, who's 11, is not thick. She's very fast, because she asked, where exactly in the Arctic do bees live, and where do they get pollen from?
So you have them all the way up to, so Spitsberg is the island that's sort of the most northern part, or like land part of the world, where there are no bees. But every other part of above the Arctic Circle, so in Russia and Canada, Greenland, Iceland, there are bees. And they're pollinating these. There are flowers in the Arctic as well, and that's what they're pollinating. But actually, very little is known about these bees, although they're incredible because they survive the most extreme conditions, and they basically, when they're active, it's they don't have nighttime when they have emerged, but they go underground for winter, and they have this extremely sort of robust life cycle that we know very little about.
Right, so
but yeah, you can find them all around the world.
There's not flowers on the Arctic ice. It's just on the land parts.
No, so they don't live on the ice. Yeah, no, it's and that's why they don't in Spitsberg. It's this permafrost. But wherever there is sort of land and where the ice melts, then you get flowers in summer. And the Arctic can be very warm in summer. Actually, you might think it's cold, but this summer in Sweden there was 30 degrees a few days in.
So are Arctic bees like polar bears? They're like big and fluffy.
Yeah, they are. They're very cute.
How big?
Because they're enormous and fuzzy. They're about 5 centimeters long. You can get really, really large ones, and they look very big, even bigger because they're covered with fur, which of course is going to be important.
So the bee itself and then added fluff. Wow.
Yeah, exactly. They're very cute. They're like teddy bears.
Okay, thank you. Our next question's for you, Meru. Was epidemiology a thing before 2020? And what advice would you give to anyone who wants to have a similar career?
It was definitely a thing before 2020. I think it's just made it easier that we don't have to explain to people what epidemiology is. The most common confusions with dermatology. I don't understand why people confuse it with dermatology, but they do. But now we don't have to explain it to everyone, so that's a silver lining of this year. It's a really cool career. You can do lots of different things. You can work in lots of different diseases. It's a methods-based field, and it has lots of different, fields that you can come into. So I have colleagues who are lab scientists like me before getting into epidemiology. There are those who came from policy background. There are lots of those who worked as medical doctors. There are nurses. So it's a meeting place of lots of different professions because those background skills add a lot to the field of epidemiology and how you really view health and medicine as a whole. So that's one of the coolest things that I like about the field. So I have a lot of different colleagues who come with a lot of different diverse backgrounds before moving into epidemiology.
I think you said at some point that epidemiology and public health goes hand in hand with politics. So the political side of it is really, really important because you're going to these different places.
Absolutely. I mean, everywhere, not just in it goes hand in hand because often you're also, especially in critical moments, there's the research side where you generate evidence and you can inform, you can publish your work, you can inform policy, you can inform practices. But also, I think often we don't realize how much you have to balance decisions. So, I mean, COVID's a classic example of, and we would have heard, many people would have heard about the discussion on do we just lock down the city for 6 weeks or 8 weeks, and what's the balance, and how do you communicate, and how does it interact with other sectors, so not just health. As much as I'd like to say epidemiology is the most important thing and health is the most important thing, which it is, there's lots of other influences that come into play. So it's a very, very, it can be very political, especially when lots of lives are at are concerned, and we're trying to prevent deaths, and we're trying to elderly or vulnerable populations. And it's not just with COVID, it's with vaccine preventable diseases, it's with smoking and tobacco control. And we heard a lot about plain packaging, and that's again a different side of public health, and not directly maybe epidemiology, but different side of public health about what influenced policy decisions around having plain packaging for tobacco, cigarettes, and sugar tax. And so those are all different elements of public health, and of course there's lots of players in the field.
Yeah.
Would you like to take the next question?
So this question probably goes to Rajika, but maybe the others as well. Do you know how to code, e.g. in Python? And if so, are there practical applications of coding in your science? And is it a skill that's highly sought after?
So because my work is purely theoretical, it is all programming. So my simulations, when we set them up, we use Fortran, which is a very old language, but we use a newer version of it, which is a bit more friendly. And I do most of my analysis in Python, which is pretty popular in the sciences, and I think it's making its way into the other field. But I have, this has been brought up in discussion before, where scientists like I talk to, where we can program, but we can't necessarily program well. So I'm pretty sure a software engineer would probably construct code a lot better. But over the many years of experience, I think I've gotten pretty good at coding up my analysis scripts and parallelization and stuff. And I think the skills I've definitely learnt in my research, I can probably transfer into industry if I do want to leave academia.
Okay, thank you.
What about analysing data? Do you need...
Yeah, absolutely. And there are lots of different statistical softwares that you might be able to use. So lots of different, I use two particular softwares like SATA and R, and lots of other people might use different things. And as an epidemiologist, we love data. And so you do. And I do completely, I think it is a highly sought after skill. Data science is amazing and it's transferable. So there are lots of these packages and softwares that you wouldn't just use in health and medicine. You might use the exact same in finance and management and other fields. Anything that uses data, and data is amazing. So I think it's a great skill to have. Yeah, absolutely.
Okay, well, thank you very much. And unfortunately, we can't get to all of the questions that people posted, so I'm sorry about that. But I did want to just include this one statement, not a question. The writer says, "You are all brilliant. Thank you."
Well, yeah, that's fantastic. So that's it. We don't have time for any more. So thank you to all our scientists. We hope you at home have enjoyed the show. And here, of course, a multitude of thanks to Bevan Noble and Jonty Davis Conyngham, Dave Wong, Ozge, Justin, Marcus, Stefan, Matt, Dean, yes, anybody else I've forgotten, and of course Nigel and Beth and Smith's Alternative. If you want to find out more about what we do, you can go to our website on dramatiscientificae.com. You can follow us on Facebook or Twitter, and if you'd like to support us, please visit our Patreon page.
Because we'd really like to do... Oh, it's not him anymore. It's just me. Well, we'd really like to do more of this, and we'd like to do it better. We're learning, we're developing
We're not
skills.
talking about the scientists, we're talking about us. Yes,
kind of.
Absolutely. So thank you once again, and it's goodbye from all of us at Adventures Abroad in Science.
Goodbye.
Thank you to the scientists, of course.
Thank you.
Thank you. Good night. Thank you
Bye.
very much to all our scientists
Thank
as well.
you.
Good night.